Okay, how we doing? Okay, right now I want everyone to rate themselves 1 to 5 on adding to the input or output. How we doing on it? 1 to 5. Let's see. We good? Okay, let's go ahead and move on. Let's turn the page. We're on page 64 now. 64 is adding to the input. All right, so the output is what you got out. That was our y value, right? So let's go real quick. Let's go back to this. Luke's question when we said adding to the output. When we picked values for x, so for instance, we did our notes here. We put 1 in for x. We subtracted 1. We got 1 out. That was an output. That's our y value. And then to that output, that was 1, 1. We added 5 to it. It moved it up 5 and put us at this point right here. Okay? And then when we put 2 in for x, 2, 2, or 2 times 2 minus 1. When we put 2 in, we get 3 out. So we get the ordered pair 2, 3. Well, we had to add 5 to that output. So 3 plus 5 is 8, and it puts us right here. So it shifts that output, this value, up 5 as well. All right, so it would put it up here, which is what we see in our new graph. Okay? Well, we're not adding to the output anymore. We're adding to the input. All right, so I'm going to make on my graph, or on my note page here, notice I just used a piece of scratch paper, so I have a little scribble off to the side. Hopefully you don't have that, but it's okay. We are now adding to the input. Well, what's my input? Is x or y input? X is your input, right? It's the number that we put something in for, or it's the variable we put something in for. It's our input. So when we're adding to the input, that's going to be adding to our x value. So in the function notation, that looks like this. F of x, or g of x, equals f of x plus h. It means we are taking a value of h and we're putting it into the inside of the parentheses here. Remember, when we did the previous one, we were adding to the outside of the parentheses. It said f of x, and then the plus 5 was on the outside of the parentheses. Here, this is on the inside. Okay? So when we had our output, that was f of x plus k is equal to our g of x. That was kind of the format. When we're going to the input, we're saying g of x is now f of x plus h. The thing we're adding is on the inside of the parentheses. So if it happens on the outside, it's affecting the output. Get that? Outside is output. If it's on the inside, it's affecting the input. So inside, input. Outside, output. I don't think that's why they named it like that, but dude, that's just awesome. And look at that pattern. Isn't that great? It's like we almost planned it like that. You guys don't look as impressed with me. Sheesh. All right. Very good. Let's see what happens. So, notice h can be negative, which would mean that we are in essence subtracting. We talked about that. This notation means, what this notation means is that we first add to our input and then use that value to calculate the value of the function as normal. So, if I take f of x equals 2x minus 1, that was the function we just graphed, right? That's still this one right here. And transform it to be g of x equals f of x plus 5, what would happen? Well, let's show what happens here. And notice they do that run-on thing again. So I'm going to write it out. Just kind of, let's write it out off to the side over here. Okay? So if I'm saying g of x is going to be f of x plus 5, notice we're adding 5 to the input this time. The way that's affected is whatever you see right here is your input. Your input, I kind of blurred it when I tried to highlight it. Okay, that input gets plugged in for what value? Not for A, for X. So we take our original function. Our original function, remember, is 2x minus 1. That's this one right here. So maybe I'll write that right above it. F of x, our original function, is 2x minus 1. And this chunk right here gets plugged in for x. It gets substituted in. It's our input. So our new input is no longer just x. It's x plus 5. Okay? So when I rewrite this, the 2 stays the same. The minus 1 stays the same. The thing that changes is x. It becomes x plus 5. Remember, we always put parentheses there. And this time the parentheses are a big deal. Tell your neighbor why the parentheses are a big deal. Okay, why are the parentheses a big deal? Sam? Yeah, you have to distribute that too. To get rid of them, you've got to distribute. That gives me 2x plus 10 minus 1, which is 2x minus 9. Now or 2x plus 9. Now you'll notice what I did here. I stopped writing g of x. And that happens a lot in math. If this side just keeps staying the same, you just write an equal sign all the way down. Okay? And at the very end, I'll put my g of x back on. So my new function is 2x plus 9. Okay, so graphically what happens? Well, here's my original picture, my original function. Okay, we have our 2x minus 1. And then when I graph my 2x plus 9, it now looks like this one right here. So remember those points we came up with earlier on this page? We had 2, 1, minus 1. Say we had 1, 1, and 2, 3. Well, that 1, 1 that was right here, and that 2, 3 that was right there, have now changed. Okay? It's moved it this way. All right? So let's take some notes on that and show how that moves. So first thing I'm going to do is I'm going to show how my function changed. So if I have f of x equals 2x minus 1, and then I'm going to take g of x, and that's going to be f of x plus 5. So the 5's on the inside now, so it affects the input. And I do the math here. This thing gets, or excuse me, not that thing this time. I messed up on my deal there. This right here goes in for just that right there. Ignore that first circle there. Okay, so my new function is 2 times x plus 5 minus 1. So the 2 stays the same, the minus 1 stays the same. The only thing that changes is that x becomes x plus 5. We do the math, we get 2x plus 10 minus 1, so it's 2x plus 9. That equals my new g of x. If it makes you feel better, you can write g of x all the way down there. Okay, pictorially, remember, when we're graphing this, we cross at negative 1. We rise 2, we run 1. We rise 2, we run 1. We rise 2, we run 1. Right? And we have that line right there. When we change that, remember, if I were to put values in just like we did up here, I am now changing my input. So if I were to say, okay, I want to take and put a value in for x. So let's use the same value, the 1. So if I'm saying x is 1, really I'm not inputting 1. What am I inputting? I'm inputting 1 plus 5. I'm adding to my input every time. So if I say, give me a value for x, and you say, okay, 1, I would say, okay, well, that means I'm actually inputting 6. Okay? And I say, give me a value for x, and you say 2. That would mean I'm actually inputting 7. Okay, so I'm adding to my input every time. So when I say I'm going to input 1 for x, that's actually, I'm still, when x is 1, okay, I'm still inputting that 1, but in essence, it's like I'm inputting a 6 there because I'm adding 5 to it. So 2 times 6 is 12, and then I have that minus 1 on the end. It's 12 minus 1? It's 11. So when x is 1, y is 11. Okay? And you would see that on your picture over here. Notice when x is 1, y is off the screen. It's like way up there. It's 11. Okay, and if we continue out that, go ahead. Question? Output is y, correct. Yes, good question. Yeah, so when I'm dealing with the output, it's affecting you up and down. Correct. So when you're dealing with the input, you're moving it this way. Okay? And so what's going to happen is that if we were to keep doing this and we were to put in, okay, you say, hey, let's pick 2 for x. So we'd have 2 times whatever minus 1. So we put our 2 in for x. Well, remember, whatever we put in, we're adding 5 to. So it's essentially like we're inputting 7, which is 14 minus 1, or 13. So that means this point that was at here is way, way up here now. Okay, which will start making you think, well, is my graph moving up again? Well, what's actually happening, if you start graphing that, you get a picture that looks like this. And the point that was here at 2, 3 is actually slid this way 5 units. So f of x plus 5 moves to the left 5 units. Moves this point that way 5 units. It moves this point this way 5 units. So the point that was at 2, 3 is now at negative 3, 3. Okay, so the output didn't change, but the input changed. Yeah. Why did I take the 9? Oh. That was just showing what we did here. Yeah, I just kind of. So the 2x plus 9, that's that new graph. Okay, you guys, it says plus 5. Does anyone look at it and go, why did I move backwards then? Okay, plus 5 you'd think would kind of go to the right, right? Everything's backwards when you're dealing inside the parentheses. It's like backwards roll. It's all counterintuitive. So if you think, hey, plus 5, I just move this way 5. Okay, you actually go the opposite of what you'd think. Okay, you go backwards 5. So that's something to make a note of. So when you're doing this and you're kind of showing a picture of it, you may want to say, okay, well, the point that I had here at 1, 1 is going to move this way 5 units. So rather than being at 1, it's going to be at negative 4. Okay, and the point that I had here at 0, negative 1 is going to move this way 5 units. So now it's at I'm sorry, the point I had at 0, -1 is going to be at -5, -1. Okay, so this graph is translated 5 units to the left. Okay. Making a note to yourself that it says +5 and you actually go backwards 5. Okay? All right. How many are with me so far? Good. Questions? Yeah. If it's inside, when I say inside, it's inside parentheses. So the question was, you got to really speak up because they can't hear you back there. So the question was, like, when you're replacing when you're putting something on the inside, how do you know it's going on the inside and not the outside? Inside means it's inside the parentheses. Outside means it's outside of the parentheses. So this one's on the outside of these parentheses. This one's on the inside with the hex. Okay. Other questions? All right. So let me give you some to try out here. What would happen to that graph of f of x? If I gave you g of x equals f of x plus 3, tell your neighbor what happens there. Okay, first question you have to ask, is it inside or outside? Outside. Inside affects which way? Left or right, up or down? Left and right. Outside affects up, down. Okay, so it's outside. So this is a vertical, right? It moves vertically. Translation. Where? Up 3. So this is a vertical. Translation. Up 3. All right, so your first question needs to be inside or outside. If it's outside, you go up when it's plus, you go down when it's minus. It's called a vertical translation, up or down. Okay? Try this one, please. Tell your neighbor what that one is. Okay. Once again, inside or outside? Inside. So when it's inside, it is horizontal. It's a translation. Okay? Now remember, it's backwards. So this is horizontal. Translation. Yeah, so plus goes this way, minus goes this way. It's backwards. So we go 5 or right 5. All right? Try this one, please. Tell your neighbor. Okay, inside or outside? Outside. Outside is vertical. Translation. Down 2. Well done. How many got that one? All right, one more. Let's try this one. G of x equals f of x plus 9. Tell your neighbor. Okay, Sam, what do you got? Inside, so it's horizontal translation, left or right? Backwards, correct? So it goes left 9. Okay, everyone rate themselves 1 to 5. All right. Good. Okay. The first step is always to identify the inside or outside, because that tells you vertical or horizontal. Always does. Okay. Hey, we'll pick up from there tomorrow.